Okay, so our source is now cached, and we're gonna drop in a .NET now to do the Pyro, but I realized that I have -1 ID points, which is coming from this scatter that we did, and ideally I would like to have a unique ID numbers for all my points, so when I need to source them in sub steps, I can use a time blend, and without the ID that's not going to work nicely. So let's make sure that we have good ID numbers. So we need basically points that are scattered and that doesn't move. So this usually shows up so many times in Houdini social networks like the Facebook pages, etc. There is, however, I mean, I'll show obviously how to do it, but there is a really easy, there's actually a tutorial on the help documentation for this, so you just need to go to Scatter's own help, and then you'll see making scattered points stick on changing geometry, which is very cool. So it gives all the details that how you should use attribute interpolate, etc., which we'll do now. So, and the way we use it is we need to create an interpolate node, and this gets destination geometry, source of attributes to interpolate. So our first frame for the sim is 1155, so we freeze the cache at 1155. Required destination geometry, so this source of attributes to interpolate, that goes in here, that goes in here, and on the scatter node you need to turn on source prim and source prim UV attributes, and basically the interpolate should take care of everything else. So if we now do a little test, you'll see what I mean. This zoom is like, I don't know, let's maybe make the points a little bit bigger. Okay, so this is without interpolate. Just gonna press play. You see how you get jittering, etc. And this is through attribute interpolate, and it's just fine. Now what we need to do here is that let's create, okay, this is also good. After the scatter, let's drop in a wrangle. So again, let's say random ID. So some of you may already know there's a button here that shows many presets, and then you can also, if you say presets through say preset from the gearbox, they will also show up here. So let's bring in something relevant that might be relevant for our task, which would be, let's say, random point color. I want to create random ID numbers based on something, so it gives me an example here. Then I have other things, the more complicated things like grow hair, which does a little bit of a loop here, so you can familiarize yourself with more complex presets. Nearest point distance, averaging neighborhood points, so on and so forth. So but now we need this guy, random point color, and instead of a CD, we're creating an integer called ID, right? ID, and because we have a consistent point number now, it's always going to return a good value. But this rand returns a float from 0 to 1. So what can we do is that we can convert this to an integer. So let's this one. So we need to multiply the result of this value by, let's say, a random number, which is going to give us a huge number. We just want a random number. Okay. Okay, I don't think we have that many IDs here. Well, we hit 20,000. We obviously don't want to have duplicate numbers as well. 600,000. Okay, so let's make sure we have another 0 there maybe. Where's our new IDs? Okay, let's, because this returns from 0 to 1, let's fit this into 1 to 10 to 20,000 or something. So let's go fit. This value is from 0 to 1, but I want 1,000 to 20,000, whatever. And this should give me a... Why is it? Oh, I guess. Sorry, let's go like that. Ooh. Okay. Sure, let's put another 0. Why not? Okay. There's so much more. Okay. So we literally fit that, but here you see there's a exclamation mark, and that's because we are casting a float to an integer. So Vex is warning us, so we can do the casting like this in linear. So we got int. Okay, so the value is now converted to an integer, and we have no more warning message. I don't think this has ever caused me any problem, but I guess if you are trying to create a solid rig, and I believe you can make a scene fail on a farm if the if it's defined to fail upon warnings or errors, so that might help with the situation. Okay, so now we have so many more points. Let's cache it out again. I'm gonna run this in the background so I can start preparing my .NET. I'm gonna save the scene. Okay, and select this guy, save this in the background. So as this is happening, let's monitor it from here. Where is it here? Okay, so it's gonna so we can see the progress. So now we are going to create another .NET. Let's color this guy black. Okay, so let's drop in another .NET. Let's call this base Pyro. Let's dive inside. So this is starting at which frame? We can define that right now. This is 1155. Simulation 1155. Let's go inside. I think we can probably let's do it from scratch, because this one is a bit more different. Okay, so let's start with a smoke object. Let's call this explosion. I think I need a new tablet. Explosion. And so we're gonna fetch all that information from outside like we did before. So we're gonna drop in an apply data. Okay, and we're going to drop in a subgeometry to bring in the points into our .NET. Okay, and we're going to change its default operation to set always, so it fetches the information every frame. And like we did before, on the subgeo we can put an input path 0, and that's going to get the first input as a source, so we need to hook that up to the first input, which is number 0, as it's indicated here. And now we need a Pyro solver, so let's drop in a Pyro solver. Again, I could have just copied this, but I believe practice makes perfect. So and this one is a bit of a different scenario than the previous one. So now what we need to do obviously is to define where our simulation is. So and to optimize our simulation. So what we're going to do now is we're going to bring in a gas resize, fluid dynamic, hook that up to pre-solve. Okay, and in let's change the padding to 1, field as it is, tracking. So we're gonna track our source by, I think we can use the our simulation cache, so it is never smaller than where the source points are. So let me lock that in. Actually, I think we want the geometry rather, because if our points run out of the sim, I think the resize box would shrink to 0 and that will just immediately kill our simulation. So I think what we need is the cached geo. So I guess we can use probably one of those, which is always in the scene regardless of which one is not so heavy. Yeah, I think this will look better. Yeah, so let's give this a no. No, this, we're just gonna use this. So where was that object? Let's lock this resize fluid dynamic. Let's find back the cache. So our container will always follow. It's gonna use the geometry to track, to auto resize our simulation, which is where always the file will be anyway. So that's probably quite reasonable. So let's define our simulation area. I guess now we can also use the bbox attribute that we used previously, which, because we have information on the first frame of our sim, and that's as big as probably you want your, so this guy here, let's call this, let's give it a name actually. Let's call it out source ETS, and we're going to use, or a bit bigger than this, we're going to use this as our starting point for our container. So let's go bbox one level up, 2 level up, and I forgot the name. Out source points. Okay, let's copy that. Okay, close, comma, X, and so it's gonna get the X value of 38. So the result is 3847, which is 3847 X min. Okay, and that's coming from the size, the X. So let's go dy. No, one second. I'm not sure if I said the right thing. It should be the size, not the. Wait, the X. Yeah, okay. The X size. I want to fetch the size. Yes, so that's correct. And now let's change. Let's get this guy again. Let's go. This is now dy size. Okay. Paste X. And now we need to get the centroid. Centroid, same object. So I'm just going to copy this. I'm going to change its arguments here, which is the x. I think that's how it was, right? I'm not doing it wrong. Yeah. Okay, and copy paste y and z. I don't want close boundaries. I have an error somewhere. Okay. Why is it erroring? It should be z. Where's the error? Bracing error. Okay, I'm missing something somewhere here. Okay. Okay, we're good now. Okay, so you see, now we have our initial bounding size. I'm just gonna multiply these sizes by 2 because I put it somewhere else. Oh my god! Because I want to give some buffer if there are fast velocities. I guess that should kind of help. Maybe gas precise filet is actually taking care of that properly, but well, why not? Okay, so let's make this quite big for now. I also like to. Did this finish? Yeah. Let me see. Okay, there's one issue, I believe. I don't know, I have to check with my system, but it should be coming from a... It's quite small, it should be very scrubbable, and it isn't, and it's bothering me because it's reading it from my SSD, and is it reading from my SSD? It is reading from my SSD. Yeah. Okay, I need to check that out. Okay, so let's go back in. So we have the particles in the .NET. Now we have to obviously tell Pyro that it needs to do something with those, right? So we're gonna start creating our gas particle to field nodes, and we're gonna start sourcing our sim using the pre-solve. So let's drop in and merge. So this guy, let's name this guy add density. Okay. I am pasting. I'm cheating. I'm pasting it from the other scene. And let's so this is what. Okay, we're gonna populate the density field using the density attribute because we have already saved those here, and then we also have fuel, and I believe temperature also. Yes, temperature. Yes. Okay. So let's go in. So this would ideally just generate smoke. So is that happening? Let's check. Not at the moment. We'll check that out as well. What I want to do is, okay, let me check something 1 second. Where's the memory? Okay, I want to cache this information for this session because I really don't want these little particles to be the bottleneck for this big sim. Okay, let's say it's good for now. Yep. Okay, let it run. Okay, I guess that's good for our testing purposes, so I'm gonna just shrink this to 1200 for now, a little bit less so it doesn't try to cache after. I want more. Okay, so let's press play. Okay, these are my points, and they need to be emitting something, and if they aren't, we need to investigate. So I'm going to assume uniform radius. I'm going to add to the simulation, and I think that's all I have to do in this scenario, except the names need to match, that's why it's not matching, so we need to call it. Is it? No, it should work. It is geometry. This is geometry, right? Okay, so that's correct. Okay, let me press play again. Okay, it isn't resizing. Why is it not resizing? Okay, let me turn that off. Okay, well, so it is moving, but I don't know, particles. Maybe it's just the density is very low. Nope. Okay, so how do we debug this? Okay, so we have our smoke object. Is that why then CT? No, I don't think so. Oh, maybe it is. Okay, also density here. Let's exaggerate. I want temperature, let's say, and I don't know, heat. This doesn't matter. Let's put 10. This is not going to show anything yet because we are not bringing in anything. Okay, let's increase our values. Maybe combustion. Let's turn off combustion. Let's turn off everything because we're debugging now. I'm going to turn on OpenCL. I have my OpenCL set. I don't remember if I mentioned it. I don't have a very strong video card, but I do have a good CPU, and I believe I enabled my Houdini to use my CPU as an OpenCL source. This has some advantages, some disadvantages, obviously. Well, the CPU is directly using the memory, so it's like as if you have a video card with whatever system memory you have, but obviously it's a lot slower than a video card. But it does make a difference, especially if you have a CPU with many cores. But I am going to disable it for now and only enable it when I'm actually sending this for bigger simulation. Okay, so then let's focus on the subject. If I put a copy, I am still not seeing any volumes. This is confusing me. Okay, let's try to figure this out. Okay, let me decrease the resolution so it's a bit faster. Okay, what are we doing wrong? The density, is it? This should be working. Yeah, I mean, if we have the points, if we just scrub a little bit, we should be able to check the geometry that is this, and these are the points, and it has density. So let's exaggerate it then to see what's the deal. Let's put let's multiply. Okay, I'm not in viewport mode. I'm not in wireframe. Oh, where are my volumes? That's very weird. Okay, I am using density. Oh, okay, there you go. Okay. This is obviously wrong because it's looking for a particle group called density. That's not what I want. That's what I want. And now, yep, now it's working. Obviously, we have exaggerated everything quite a lot, so let's bring that down. Did we have p-scale on these points? We do not have, but we have age. So ideally, we should use a reversed age for emission amount, which means that when a piece gets broken, it flies away, gets older, loses fuel or density over time. Okay, so we can, I guess, use that. Let's not assume uniform radius. Let's press play. Okay, I guess now the resolution is quite low. If I want F1. Okay, let's put a time blend in here. Okay, let's put a time blend. This time blend will use the ID attribute, use velocity when interpolating position, smoothly interpolate normal quartiles and transforms. So this guy is going to allow us to interpolate if we are using substeps, and I always advise to actually visually see that your substeps are working, and the way we can do that is, so let's do a comparison. At the moment substeps is 1, this is within substeps, this guy is the solver substeps. So what you can do is that, okay, so it's now it is working as it is, right? Yes. So, but does it work if I am substepping? So you can always turn off the integer frame values, and let's say, let's put 0.25. So that's basically 4 substeps, right? 1 divided by 4. And if I press play now, and let's go frame by frame. So you can see that my frame counter changed from 1155 to 0.25, and my points are moving every step. New set of points are created. Everything is moving. New points of set are created, so on and so forth. So until the particles are emitted, the stepping look-alike behavior is coming from, because my points are emitted in mid-air. So if you want to get that even more accurate, then we need to go back to this stage and save our cache with $FF. So we need to have the IDs here. I guess we can do that, but then for this to work, we need to cache the frames out from these guys appropriately. Where are they? So we need to be careful on substepping, and that's pretty much the only way to. Because at earlier stages we have the geometry, so we can create actually a lot more accurate sourcing, but it is extremely important to have a proper source that doesn't step. If it's cached out, it needs to be cached out with $FF, so it's always and if there are points, it needs the IDs, so you can interpolate. If the geometry, it shouldn't have a changing topology. If it does have a changing topology, then you should cache it out as the simulation is happening with $FF, but then your .NET needs to have substeps, etc. Okay, so I thought we cached this out. I don't know what happened. Okay, so let's press play. So this is our particles creating points. Let me try. Well, I don't think we have p-scale. No, we don't. Okay. What if we create one? What if we want to change the size and the emission based on age? Yeah, let's give it a go. So let's open a web. Let's call that emission settings, emission source settings, So let's say I have age, right? This is here. Let's hook that up to CDC, what it does. We need to have the flag on the WOP. Oh well, these guys don't have age. And how do we make age for them? Okay, so we decided to do something smart and we shot ourselves in the foot. Now we need to create an age attribute for these guys. And let's say it's some other guy did this sim. These are points. The cache underneath is geo, but geometry don't have age. You say maybe, but well, that's not really true. So anything in Houdini is possible by some sort of imagination, let's say. So how do I create age for these guys? So what do I have as a reference so then I can age it to? So these guys at previous frames to 1155, they're not moving. So one thing they have in common is that they don't have their position changing, and the other thing they have in common is that they all have their speeds equal to 0, right? So therefore I probably can use both of these, or even just the speed, seems to me like, as a rule to age these guys, right? So let's do that. So how do we do that? I have the points here. I have these points diminishing here, so because I have this keyed out. So what I'm going to do is that I'm going to do the aging in between here. In order to do that, we need to add points on top, so we're going to use a solver SOP. And I'm going to, I always get confused with this solver SOP, but I guess we'll be fine. Start frame, we're going to change it to 1155. 1155. Did we calculate speed anywhere? No. So let's go inside the previous .NET that where we created the density, and let's create. Actually, we can also. I'm going to use as many different tools as possible. I want to create a rest position, which this guy is here, does this, which is no different than at the moment, at least for the this version we're using. Because we have at that stage sorry, not here, let's do this here, because this is where the part that nothing moves, right? So let's use it here, and all the velocities are 0. So what I'm gonna do is that I'm going to create under this random ID at velocity equals 0. Resetted everything, okay? But here, that's not true. So I'm gonna recalculate these velocities because I'm not trusting the previous ones. Okay, so I got new velocities. Let's visualize this, and then we can always tell Trail to use ID. That seems to break things. Let's turn off ID. Well, we don't need to use ID, yes, of course, because we have consistent point count. That's fine. Okay, so now I can use the solver SOP, but I need to create an attribute called age. So let's say f at age equals 0. Oh, this keyboard. F at age equals 0. Also, I got some feedback that my keyboard strokes were quite strong, so I'm sorry. I'll try to, I will try, I mean, the lesson is coming to an end, but for the next one, I'll try to be much more gentle, or at least get a silent keyboard or something. I think that's a fair request if I am to continue this, to get a bit more suitable hardware for recording videos. But you don't know until you start recording videos, basically. Until you start listening yourself, like, oh my god, I'm so loud. And the keyboard is on dang, dang, dang. Okay, so what are we doing here? Create age attribute, which we can also use an attribute create, an attribute expression. Yeah, I think Sesi is just making way too many tools to do the similar tasks. It's just more convenient for sure, but the file size is over a gig now. So let's call it 0. Okay, so anything basically here, right? Anything here is 0, which actually could be here also. But I did say where, and where did the we removed it by accident. Okay, so let's say age is 0. Let's do the at v equals 0 here as well. Okay, so everything is 0 speed and also an age of 0. So now we need to go in here. So this is the previous frame. This part I always get confused. Let's put a wrangle. And let's put an attribute copy. So I want to copy the age. I want to add to the age. Right? Which one do I do? So this is the previous frame. Okay, attribute copy to current frame, previous frame, age. And then age equals +1. No? F at age plus equals 1. I'm gonna change that later on, but let's see if this is gonna add up first. It should work for everything, for not timestamp steps. Oh, that's the problem. Okay. Put it in the wrong place. 11:55. Okay, so now everything should increase, right? Everything is increasing, same, because we're just adding. We didn't put any condition, and our condition will be float speed equals at velocity length. Okay, so then we say if speed is not equal to 0, then do this. Now it's gonna be the points only will age if they're only moving, right? Which is kind of working now. Okay, so what do we do with that? So I guess we don't want age, we want FPS, was it? At FPS, is it FPS like this? I'm not sure if it was, no, that's not like that. No. Framing, it's the frame inc, incremental frame inc, no, frame, frame increment, frame inc. Am I remembering this wrong? There's a way to check that, obviously. Not what network, sorry. Just dropping a whoop. I just want to check an attribute that I cannot remember. It's this guy. It's timing. Is it timing? Maybe it is. Time increment. I don't remember. 1 second. Let me try to figure it out. At time inc. I'm just using my imagination, I think. Okay, let me. No, it should. If it's creating another attribute, it shouldn't be. No. Okay. You know what? I'm just gonna Google it for a second. Time inc. Lini. find the answer in the help itself. No, no, no. Somewhere here? No. Where? Let's go. Let's search. Time. Next. At time. Time. There we go. We got it. Okay. Thank you. Help documentation. It should work, right? Okay, now if we go out, press play. Yeah, it's working now. And now what we're gonna do is that we want to use this here. So let's plug that guy up here. And just like the other guy had the H, now this guy has the H as well. And let's save this in the background again. Save, not save as, save. It's way faster. Maybe we should call this Solid Pyro from now on, even though we're a bit ahead of it. Okay, save. So okay, so let me do another background. Yes, please. Please save. And we have the H, so now we're gonna, while this is cooking, well, it cooked a bit faster than I think it should, no? Oh, what happened? Why is it empty? Didn't work. We are erroring somewhere. Let's follow the trail. Where is my cache? Base sim cache. Is this in its place? This one is. So where is this one? This one and this one are empty. I think, and this one are empty. So is this one. Okay, wait a second. Ground source cached. Terrain baked. Well, geo. We're looking for ground and I don't see it. Heap name. Oh. Well, yes, of course, because we just changed the name. Well, that's stupid, no? Okay. Yeah, because it's the heap name. Okay. I think I mentioned not to use the heap name before and we just did. Okay, so it's because I think it's looking for 06, which is these guys, so we're gonna hand select them. So ground source cached, ground source cached, spark source cached, spark source cached. Okay, now and base sim cache, again looking for solid sim, base sim cache, oh my god, and ship sim cache. Well, to avoid issues like this, and at my workplace at MPC, and I believe in a lot of other places, we don't try to use relative paths, but instead absolute paths, because of issues that may occur, just like it did now. So let's do another save. Yeah, that's, and then occasionally we get like, I get like so many questions saying, but it works locally on my machine. Yes, and majority of the time it's because of TD tries to use an absolute relative path instead of an absolute path, and sometimes most of the time, because when a job is submitted, usually it's a copy of the actual file, not the file itself, and it gets its own versions and naming and this and that, and then $hip just cannot ever find it, which is very predictable behavior. Okay, so back to what we were doing. Now we should have the stuff here. Yes, that's good. Okay, and now they should all have age. If not, yeah, that's all good. And here now we're gonna create our emission. So before everything was everything on the edge was stained black, but now obviously they are all varying. They're getting white as they get older. So what we're gonna do is that we're gonna go to the lost frame. And we're gonna hold the lost frame, which is actually 1300. We did save it to 1300, right? Yes. Okay, and there's nothing in 1300 because everything is deleted by then. Or is still cooking. No, it's not. Let's extend this to 1300. Let's find that. Let's find a frame that has not much. So we do have points in 1300. Why did it? This is awfully confusing. Okay, now I have the points here. That's frame 1300, that's frame 1300. Where are my points disappearing? Should I have 54 points exactly? Okay, time shift, let's go back. 1299? Seriously? Okay, well, go figure. So what I want is, well, actually, you know, that's too much extra work. Let's just go to last frame and let's go to the last frame and try to get the age, reversed age connected to p-scale and fuel and density. And to do that, let's dive inside. We had the maximum value here, right? It's 3. So let's go here. Let's say fit, bring in age. What is it? 3. So I reversed it. And if I hook that up here now, everything will start white and they'll turn darker as they get aged, right? That's the whole idea. Except that guy. Wait, why? Why is it not? Oh, because it doesn't exist in that frame. 2.65. Oh, we need to normalize this somehow. Those guys disappear. Goes all the way to 4. Okay, so that's because, why? Because these are separate. Okay, so I'm not going to merge them. I'm going to separate them. I'm going to keep them separate. where is this? This guy is here. What I'm gonna do is that I'm gonna get two separate caches. Okay, one of them will be the cache from ship, pyro. Okay, let's go with ship, and then I'm gonna do another one for the base. Maybe we can put more fuel in here and not so much in here. Why not? And we're gonna do like this. We're gonna do like this, and then this is gonna go like this. It's gonna be even more interesting. Okay. Maybe outsource PTS ship, and probably it's better if you just drop it in here. And do the same here. Okay. Let me check how long it has been. We've been recording for a while now. 51 minutes. I'll connect that to 1 hour and then start another one. Okay, so this is base. And we are going to not use the heap names. F4. Do the same for this guy. $F4 to 1300 to 1300. All cashed out. Okay, save again. And save to disk in the background. Should launch two background tasks. Let's clear the complete ones. And now we can continue. Okay, so this guy, let's go on with this, let's say for now, and we're gonna multiply, because previously we're gonna do this. Okay, and we're gonna put a ramp, and I'm gonna say remap source. Okay, that will be the name outside as well, and it's gonna be a spline, and then this is going to override our, we should bring this guy here, and wait a second, yeah, no, okay, so we're gonna bring in density, we're gonna bring in temperature, and we're gonna bring in fuel. That's all we have, I believe. Okay, fuel liter? No such thing. Okay, and we're gonna export out density. Let's call it density out. Now come on, density out. This is density. Copy paste. Temperature out. Copy paste. This is not right. This is fuel. And we're gonna move the fuel here. Okay, so now we have a lot of control on our sourcing. Obviously, wait, there's something wrong. This is, no, that's correct. Why is this colored up? Sorry, wrong connection. Obviously, we can manipulate all these three separately, but I am not going to go that way. It's just going to make it much more complex, which possibly we don't want. I'm going to save for now, and I will continue in the next video.